When an angle with its vertex at the center is rotated through a distance equal to the length of its radius, then we say that the angle measure is 1 radian. Let me show you a picture of what that would look like. Here's my terminal side, which I'll label as R for the radius. And what I'm then going to do is draw an arc which has the same length as this R. Except the very common way to label an arc length is S. And we measure this angle where the terminal side is right here, the initial side is here. Instead of in degrees, we can measure it by the length of that arc. And in this particular case, remember that what we're saying is the way that we came up with a radian measure is that the length of that arc is equal to the radius. Now, the most common circle that we use for measuring radians is the unit circle. And the unit circle has a radius of 1, which means when we make one complete revolution around the circle, that with a radius equal to 1, that tells us that's 2 pi radians. And that if we only therefore go a quarter of the way, it's pi over 4 radians. I'm sorry, pi over 2 radians. And if we go halfway around the circle, we have pi radians. So let's look, though, at the relationship that leads to the development of the conversion from degrees to radians and from radians to degrees. And of course, that'll involve fractions. And here's our first one, converting degrees to radians. In that case, we multiply by pi over 180 degrees, which is a radians now, and then we simplify. For converting from radians to degrees, though, we have a similar conversion factor, and in this case, we can take a look. It's multiply the radian measure by 180 degrees over pi, and then simplify. Let's look at actually doing a conversion. So the example that we have is to convert 60 degrees into its equivalent radian angle measure. So to do that, we take 60 degrees and we multiply by the conversion factor, which is pi over 180 degrees. In this particular case, of course, we can reduce this to 3. That reduces down to 1. So we get a value of pi over 3, and that's in radians. And so 60 degrees is equal to pi over 3 radians. When exact values involving pi are required, the calculator can only be used to check your solution, because the calculator only has so many decimal places, and then it cannot display any further out. But let's take a look at using the calculator to convert from degree measure to radian measure. So the way that works is like this. So let me plug in 6, 0, and then hit the second key, followed by the angle key, and you'll see it's now giving me a choice in which number 1 is the degree measure, so I'm going to hit number 1, and you'll see that it puts the degree measure onto the 60, so it knows it's 60 degrees. When I hit enter, it is then going to give me the radian measure. Now you say, well, that doesn't look like pi over 3. Well, that's okay. What I'm going to do now is let's use the calculator and actually plug in pi divided by 3 and see what real number that gives us on the calculator display. And if it matches, which we expect it to, then we'll know that the 60 degrees changed to pi over 3 is then equal to that decimal value of 1.04, etc. So let's do that. Let me plug in pi over 3. So this time I hit second and then pi divided by 3 and enter, and you'll see that they in fact match one another. All right, the next thing we're going to discuss is finding arc length, and that'll lead to solutions of all types for very interesting application problems. First, we will define arc length and then use the definition to solve application problems. The length S of the arc intercepted on a circle of radius r by a central angle of measure theta radians is given by the product of the radius and the radian measure of the angle. Or, in mathematical terms, S is equal to r theta, where theta is measured in radians. Let's do an example in which we use this definition of arc length. So the example I want to do is find the distance in kilometers between New York City, New York, whose latitude is 41 degrees north, and Lima, Peru, whose latitude is 12 degrees south. Assume the cities are on a north-south line and that the radius of the Earth is 6,400 kilometers. Round the answer to the nearest 100 kilometers. So to do this problem, we have to use S equals R times theta. And now if we look at the New York City, New York, which I'll label right here, compared to Lima, which I'll put down here, what we're told is that New York is 41 degrees north and Lima is 12 degrees south. So if I put the equator here, then I know that this is 41 degrees. And I know that this is 12 degrees. And so the total degree measure from here to here is simply adding those two to get 53 degrees. Now, I've drawn that as a straight line, but what we need to remember, of course, is that's on the curvature of the Earth. So now I'm going to take a side view of what this would look like. In other words, we actually are measuring a curvature in which this is 53 degrees. This would be New York. This would be Lima. And we know that the radius of the Earth is 6,400 kilometers. So therefore, I take my equation, arc length is equal to radius, which is 6,400, times, well, we want to do 53 degrees, but of course, we need to convert that by multiplying times pi over 180 degrees. And that converts it to radian, which of course is a measure in real number format. So we multiply the 6,400 times the 53 times pi over 180, and that'll give us the arc length. S is equal to approximately 5,900 kilometers. All right. Now that you've seen how to solve an application problem using angle measures, I'd like to give you an opportunity to solve a problem on your own.